Welcome to complex analysis, that is SMA 404 and stroke 414, that is complex analysis 2. So recall, we'll go straight, recall that if a function f of z is analytic inside and on a simple closed curve C, then the closed integral along that path C of f of z with respect to z will be equal to 0. So in complex analysis 1, we are referring that one to be the Cauchy-Gaussat theorem. So it is referred to be the Cauchy-Gaussat theorem. Then that if we integrate a function, that function should be analytic. An analytic function, it means the function is differentiable. You can differentiate that function at any point. So if you differentiate that function and then that point is analytic, the function is analytic everywhere along a simple closed curve or on that closed curve, then the closed integral along the path will be equal to 0. And then we go ahead and say that if a function f of z is not analytic, that means it is not a differentiable at any point. Refer to the point as z0. Then there exists a singularity of f of z at z0. So a singularity, basically, a singularity is a point where the function fails to be analytic. A point where the function fails to be analytic. Function where the function fails to be differentiable is referred to be a singularity. So we have something that we call an isolated singularity. An isolated singularity. So we always say that a point z0 is said to be an isolated singularity if there exists a deleted neighborhood of z0 such that 0 is less absolute of z minus z0, which is less than epsilon. So a deleted neighborhood, it means in layman's language is that if I pull out that singularity, then I will not find any other singularity in the neighborhood of that z0. Okay? If I pull out the singularity z0, then I will not find any other singularity about that point. The function will now be analytic. Epsilon is just a small number, so it represents the neighborhood of that number. For example, if z0 is this point here, and then the neighborhood of the z0 is this circle, so there is no any other singularity in this neighborhood, and then you say that is an isolated singularity. So a singularity is said to be an isolated if there exists a deleted neighborhood of z0 such that 0 is less than the absolute, the modulus of z minus z0, which is less than epsilon, where f of z is an analytic function. So consider examples. F of z is equals to 1 over z squared. So where will this function 1 over z squared have an isolated singularity? Now the first thing we check is that where will this function fail to be analytic? Where will this function fail to be differentiable? Now you can see that when I put z is equals to 0, this function will be 1 over 0, which is undefined, and therefore it fails to be analytic. Therefore, at point z is equals to 0, this function fails to be analytic, and that one we call an singularity. So at z is equals to 0, it is a singular point. It is a singular point. Why? Because it makes the function fail to be analytic. It makes the function non-differentiable. And therefore, at z is equals to 0 in this function, 1 over z squared is a singularity. Now the next question is it an isolated? The answer is yes, that in the deleted neighborhood of 0 of this function, the other points will always be analytic. So it's only at the point z is equals to 0 that this function fails to be analytic, and therefore z is equals to 0 is an isolated singularity. Number 2, you can see f of z is equals to z cubed plus 1 over z squared into z squared plus 1. Now normally we always say that for a function to be analytic, or if you want to find the singularities of a function, then the denominator should always be equal to 0. So in this function, I'll just say that z squared plus into z squared plus 1, that one is equal to 0, is equal to 0, is equal to 0. So it means that z squared, it means that z squared is equal to z squared is equal to 0, and that means that z is equals to 0. Similarly, z squared plus 1 is equals to 0, so we can just write something here that z squared plus 1 is equal to 0, is equal to 0, is equal to 0. So that implies that z squared is equal to negative 1, is equal to negative 1, is equal to negative 1. And when you find the square root of this, you realize that z is equal to plus or minus root of negative 1. So z is equal to the square root of negative 1, like that. So the square root of negative 1 is just I, and that's why you see z is plus or minus I. So those are isolated singularity, because at z is equals to 0, you not find in this neighborhood any other singularity. At z is equals to plus or minus I, you not find any other singularity, and therefore it has 3 isolated singularities. Number 3, f of z is equals to 1 over sine pi over z. F of z is equals to 1 over sine pi over z. Now, when you look at this function, which function are you talking about? This function f of z is equals to 1 over sine pi over z. We have said that for this function to fail to be analytic, then the denominator should be equal to 0. That is, sine pi over z should be equal to 0. So at sine pi over z is equals to 0, what can we learn about that? So at sine pi over z, at sine pi over z is supposed to be equal to what? Supposed to be equal to 0. Supposed to be equal to 0. Now, at which values will we get this function equal to 0? We'll only get when z is equals to a number of values, that is 1 over n. When z is 1 over n in this function here, that is when we'll have this function to be equal to 0. So we can have a range of values that is from 0, 1, 2, 3, 4, 5. For example, if z is 1 over n, then it means that function is the same thing as sine n pi, sine n pi, like that. Now, where will this function be equal to 0? It will be equal to 0 for a range number of values, where n is equals to 0, where n is equals to 1, where n is equals to 2, where n is equals to 3, where n is equals to 4. It will be 0. But now the question comes in that, now, can n be equal to 0? The answer is no. For our reasoning, we know that when n becomes equal to 0, it means that z will be 1 over 0. N will be 1 over 0, which will not make sense. Because z alone itself will be a singular point at 0, like this one. yeah, and then pi over 0 is already undefined, and I want the entire result of sin pi over z to be 0, and therefore at z is equals to 0, yes, it is a singular point, but it is not isolated, because at z is equals to 0, when I remove z is equals to 0, I will still find other points that will make the function fail to be analytic. It will make the function fail to be analytic, and therefore we can find another singularity in its neighborhood of when n is equals to 0. And that's why we say that n here can be plus or minus 1, plus or minus 2, plus or minus 3, and so on and so forth. Then lastly, f of z is equals to ln of z. So this function fails to be singular point. So you can see that this function will fail to be differentiable, it will fail to be analytic when z is equals to 0. Because when you press ln of 0, you find that that function is undefined. ln of 0 is undefined. And therefore, yes, z is equals to 0 is a singular point. But the next question is it analytic? The answer is no. Why? Because in its neighborhood you'll still find another singularity. So if you investigate properly this function, is that if you have geometrically, if you have a graph, a Cartesian plane at 0, this is point 0, and then you will have something that we call a branch cut, that this function will be analytic in its neighborhood just above the point 0. That's why you can say that this function at z is equals to 0 is not an isolated point. Another student can say that a function ln of z can be written as ln the magnitude or the modulus of z plus I the argument of z, written as theta. Now, when you put 0 at z, then this function will turn to be negative infinity plus. And then the angle will always run from negative pi because of the semicircle, from negative pi to pi, because of the semicircle behavior of itself. So I theta, for example, should be pi I. Then if you try to investigate this thing, you'll find that it's still giving the infinity analytic function fails to be analytic. And for that reason, we say that z is equals to 0 is a singular point, yes, but it is not isolated. Thank you.